Hello learners, I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. As you remember, in last lecture we discussed about the type of flooring and diagnosis of defects in flooring. Now we will discuss about the common defects in flooring and also the repairing of floors. So let us begin with the common defects in flooring. First of all, it is very obvious that floors are not a high risk area, but in recent years failures have occurred, particularly in concrete streets. How? These failures have occurred by chemical attack, usually by sulfates on the concrete base slab, and secondly through insufficient proper support to the slab by inadequately compacted hard core. So these are the two main reasons. Let us see these one by one. First, let us see hard core. The main purpose of hard core is to fill small depressions on site and to adjust the quantity of cement needed in an oversight slab following removal of topsoil from the site. The hard core provides a good working surface and in a way reduces moisture uptake from the ground. Materials mostly used in practice are broken bricks and tiles, blast furnace slag, various shales, quarry waste, gravel and crushed rock. These are used in the hard core. Now let us see that how the defects come into picture. So first here we see that hardcore and sulfate attack. A particular hazard to concrete floors can arise from the presence of soluble sulfate in hardcore or in the groundwater. Sulfate can attack the binded cement in concrete. The severity of attack much depends upon the type of sulfate present and the level of water table. For example, broken bricks and tiles may contain soluble sulfates and may be contaminated with gypsum plaster. Coal mining waste also contains soluble sulfate. Attack by sulfate on concrete floors may be manifested initially by lifting of the floor, and as attack proceeds, major lifting and arching can occur and the concrete surface cracks, as you see in this figure. Here you see the cracks on the floor. These cracks are quite wide and long also. There may be some movement of the external wall near the DPC level also. These expansive forces are very slow to develop and such movement may not become apparent for several years. They are so slow. How this sulfate attack can be avoided? The sulfate attack can be reduced by using materials such as coarse sand, gravel, crushed rock, clean concrete, rubble and quarry waste, which are usually free from soluble sulfates. It should be ensured that the concrete placed is of low permeability, because if it is of low permeability, it will not allow the penetration of the foreign material. If there is still a possibility of attack, cement low in tricalcium aluminate such as sulfate resisting Portland cement can be used. Where soluble sulfate are present in hardcore, a water barrier such as polythene sheet at least 0.2 mm thick should be placed to separate the floor slab from the hardcore. Now let's see swelling of hardcore. Similar damage can be caused to floor by the swelling of hardcore. Materials likely to swell from these causes are principally slags derived from steel making, refractory bricks in chimneys and furnaces, These materials should not be used as hardcore. This should be kept in mind. Then compaction of hardcore. How does it affect? If hardcore is not thoroughly compacted, it will not be consolidated later after the building has been completed, and a solid ground floor slab will no longer be supported adequately over its whole area. This is particularly likely to happen when the depth of hardcore used is excessive, as may occur on a sloping site or where deep trench fill has been used for foundations. First sign of trouble is usually the appearance of gaps between the floor and the skirting portion, as you see in this figure, that the floor and the skirting portion, now they are separated. There is a depression in the floor. To avoid trouble, hardcore should be compacted as far as possible, because if proper compaction is there, such type of problems will not be there. Damp proofing of floors. To prevent the rising of moisture from the ground and into the floor finish, provision of damp proofing both in the walls and in solid ground floor is necessary. Many types of materials are available. Selection of DPC has to be done with relation to resistance to ground moisture penetration. If polythene sheet is to be damp proof membrane, then it must have a minimum nominal thickness of 0.25 mm and a minimum spot thickness at any point of 0.2 mm, and the laps between sheets must be double welded. Where there is a overlapping of the sheet, it must be double welded. While providing this membrane, utmost care is needed to ensure for not puncturing it by services, that it should not be punctured by any of the service. Next we see the concrete floors. The main problem with concrete floors, including granulithic and terrazzo, apart from sulfate attack, is that due to shrinkage of concrete. Means here the shrinkage of concrete is a very big problem. On drying, due to shrinkage, floor tends to crack and exert stress at the interface between the floor and floor screed and finishes. Most constructional problems have occurred on concrete floor screeds. Means that screeds are the most affected portion. If a screed has to be applied, care is needed to get a good bond between the screed and the concrete base. If bond is poor, then shrinkage stress are high, the screed will crack with a tendency to curl at the edges of the cracks. Such area will sound hollow if tapped. If you tap that portion, because now curling has done, it has lifted, so if you tap that portion, then there will be a hollow sound. Finishes applied over the concrete screed such as tiles and sheet covering are also likely to crack and split and ultimately lose their adhesion to the screed. There are several factors which enhance the shrinkages and cracking of concrete screed and weaken its bond to the basic concrete. These factors are: first one, inadequacies in the mixed design of screeds and of the base on which it is to be cast; poor texture of the surface of the base concrete. Third one is too long interval between casting the base concrete and the screed. Means that gap should not be too long. Then fourth problem is inadequate curing. Then the last one is the too thick screed. means screed should not be very thick. The mixed proportion of the screed should be such that the ratio of cement to aggregate should not be greater than 1:3 or less than 1:4.5 by weight of the dry materials. The amount of water used should be just sufficient to allow the screed to be properly compacted. Means there is a restriction on the amount of water also. As water content increases, so does screed shrinkage on dry. Means more the water, more shrinkage. And the amount of latence also. When dry, it shows crazing of the surface. That is the problem. The base concrete should have mixed proportions not lesser than 1:2:4 and should be thoroughly compacted to provide a strong foundation. If concrete screeds dry rapidly, the risk and extent of cracking are increased, and the concrete is likely to lack the strength required to withstand the shrinkage process. So that way, that drying should not be rapid. A simple protection method will be by covering with polythene sheeting for at least 7 days and then allowing the screed to dry naturally. So that way you can increase the drying period. Now next we move to granolithic concrete and terrazzo. Granolithic concrete is the concrete which is suitable for use as wearing surface and is made with aggregates especially selected to provide the surface hardness and texture required. This type of finish is done for factory floors. The difficulties that have occurred with granolithic concrete are shrinkage, cracking, poor bond to the base concrete, and dusting of the surface. These are the problems with the granolithic concrete. Terrazzo consists of a mix of cement and a decorative aggregate, usually marble. And if we talk about the size, then the minimum size of 3 mm, and this is laid on a concrete screed. The failure that have occurred in such type of floors are of cracking and crazing and also lack of good bond to the screed. These are the three problems: cracking, crazing and lack of good bond to the screed. The surface crazing is increased by too rapid drying. This has been a common problem caused by failure to cover the terrazzo with sheeting. So if you want to avoid this failure, then cover that surface by sheets so that there is no rapid drying. Move to the another type of flooring, that is timber flooring. Here the biggest problem is the moisture. Moisture poses the main problem in this type of floor and it can cause decay and movement of the floor. Timber floors, whether of board, strip, block or mosaic, they need to be kept from becoming damp. Dampness should not be allowed. Timber in contact with a concrete base needs to be protected by a damp-proof layer, either with a surface or a sandwich membrane. It is recommended that before laying the wood floor, the state of concrete base should be checked for humidity. Means that humidity should be within the limits. Normally, relative humidity up to 80% indicate suitability to receive wood flooring. Dry rot attacks timber floors and skirting through infection from hardcore containing pieces of decayed timber. Means if in hardcore there are pieces of decayed timber, then there is a possibility of attack of dry rot. The dry rot fungus is adept at spreading and penetrating cracks, means it moves to the cracks, and this can occur in the concrete when hard core settles under the load. When there is a settlement in the hard core, then this thing may occur. If dry rot does occur through infection from timber in hard core, condition is difficult and the repair is costly. Prevention is greatly preferred by thorough inspection of hard core and the removal of any wood in hard core before further process. Suspended timber ground floor need to be adequately cross ventilated by providing air bricks to give at least 3000 square mm of open area per meter run of external wall. So if you do that, you can ensure the proper cross ventilation. A common defect with wood block flooring is due to expansion of the blocks through uptake of moisture. Means by absorbing moisture, there will be expansion of the blocks. When the forces associated with this expansion can no longer be accommodated by compression of the blocks, the latter will usually lift and arch, either separately from the adhesive which fixes them to the base concrete, or by pulling the adhesive away from the concrete. So these are the two possibilities. The position of lifting may occur anywhere, but it is most common at the perimeter of the floor. Probably the most common cause of moisture penetration in wood blocks is through failure to provide an adequate damp-proof course under the block. If you want to avoid this situation, then what we can do, that provide adequate damp-proof course under the blocks. Hence, in order to minimize potential movement, that wood blocks and indeed wood flooring of all types are laid at moisture content likely to be close to that encountered in service. Means we should do this flooring at a moisture content which the building has to see in its service life. It is also necessary to provide a compression joint. For example, a cork joint around the perimeter of floor should be provided. A less common defect is caused by using blocks at too high initial moisture content. When shrinkage occurs, gaps develop between the blocks which spoil the appearance of the finished floor. There may also be some curling effect. Now we move to clay floor tiles. Now the failure in such type of flooring may be caused by differential movement between the base concrete or screed and the tile finish. Burnt clay tiles and the concrete have somewhat different coefficient of thermal expansion. And as you know that when there is a difference in the coefficient of thermal expansion, then there will be a differential amount of change in the size of the material with change in temperature. So what will happen? This will lead to differential amount of movements of base and the tile with temperature changes. Freshly laid concrete bases or screed shrink appreciably as they dry, and drying shrinkage may well be opposed to moisture expansion of clay tiles, which occurs as moisture is absorbed by the tile. Means one thing is shrinking, another one is expanding. So the two effects are of different nature. That is the problem. Failures due to contraction of the concrete and expansion of tile are manifested by arching of tiles, often over a large area, or the forming of ridges usually over one or two rows. In such a case, the tiles separate comparatively clearly from the bedding, and there is a general disintegration of either the tiles or the screed. The worst condition would occur if newly fired tiles were firmly bonded to a new concrete screed and maximum moisture expansion and dry contraction movement could be expected. Tiles should not be used fresh from the kiln. Even aging of a fortnight will greatly reduce the irreversible moisture expansion. The tiles are bedded in mortar onto a separating layer such as building paper, bitumen felt or polythene. The separating layer have the additional advantage of giving some resistance to the passage of moisture from the base into the tile. However, even with their use, suitable construction joint for movement need to be provided around the perimeter of the tiled area. Intermediate joints are needed in large areas and at points where stresses in the concrete base are most likely to occur. The concrete base and screed should be fully mature before tile laying begins, and after tile laying, the floor should be closed to all traffic for 4 days after completion of tiling, and then only foot traffic permitted for a further 10 days. Now we move to another type of floor, that is plastic sheets and tiles. Sheet and tile flooring made from thermoplastic binders, mainly PVC, are applied mostly to concrete screeds, and the common cause of failure is through moisture passing from the screed. The adhesives become detached from the concrete surface, though often remain well attached to the plastic flooring. The sheet or tile gets loosened, the edges lift, and damage may then be caused to them by normal traffic. Because if there is a lifting or dislocation of the tiles, then if any traffic is passing over that, then they will get damaged. Then degraded adhesive oozing through the joints may also cause staining. That is another problem. Sodium carbonate can be left behind following evaporation of water, which has penetrated through the joints in thermoplastic and vinyl asbestos tiles. Such a deposit will not in many cases prove harmful, though it affects the appearance. Sometimes inadequate bond between adhesive and tile can occur even when conditions are dry. This is caused by too long delay between spreading the adhesive and laying the tile, leading to loss of surface time. This is a fault of workmanship and is manifested mainly by the looseness of individual tiles. In order to take up repair, it is very much essential to know the cause of the failure, because if you do not know the cause of the failure, you can't do the proper repair. It may be possible to reuse loosened tiles or sheeting if all that is needed is to give more time for the screed to dry. Another type of floor is linoleum floors. Linoleum provides a satisfactory floor for residential and public buildings, railway coaches, ships, etc. It is also suitable for most type of non-industrial floors. In light industry, such as in electronics industry, linoleum flooring may be used as the risk of damage by cutting, for which linoleum is less vulnerable. For the efficient planning and execution of the work, The essential information required is first, purpose for which the floor is to be used. Second, the floor area to be covered. Then details of the floor, and finally the type of soil in the sub-base and any seepage problem, etc. IS 1198/1982 gives the code of practice for laying, fixing and maintenance of linoleum floors. Suitability, material, preparation of subfloors, laying, maintenance, details of linoleum floors are given in this code. The thickness recommended are 4.5 mm and 3.2 mm for commercial and institutional building respectively, and 1.6 mm for domestic. Where traffic is low, linoleum is not suitable for installation except when it is wholly inside the building. It is resistant to oils, fats, greases. Thicker gauges shall be used where heavy traffic is expected. Linoleum is not resistant to indentations. Keep in mind, it is not resistant to indentations, particularly from heels and static loads. Linoleum, when highly polished or wet, can become dangerously slippery. This is the problem. This is the great problem, that if it is wet or if it is polished, then it is very slippery. So accidents may occur due to the fall while walking over such floors. The timber subfloors and concrete subfloors shall be given as underlays for this type of floor. The type of adhesive to be used and the manner of use shall be those recommended by the floor covering manufacturer, and the adhesive shall be compatible with the floor covering and suitable for bonding the floor to the underlay or subfloor. Linoleum should be stored at room temperature of not less than 20 degrees centigrade for at least 48 hours before it is unrolled. It shall be laid out flat for several days before it is cut to size, because it is having a very peculiar property that after being unrolled, it shrinks in length and expands in width. When two widths of linoleum meet, they shall be left with one overlapping the other until expansion has stopped, then cut to the size. Linoleum shall be laid either loose or fixed to the subfloor by means of suitable adhesive. Any priming coat should be allowed to dry before the adhesive is spread. Adhesives are spread with a closely notched trowel as recommended by the manufacturer to ensure even the coverage of the subfloor to the correct thickness. The area shall be well ventilated even when non-flammable solvents are used in the adhesive. Smoking shall be prohibited while doing this such type of flooring. The base area on which the linoleum is to be fixed shall be thoroughly cleaned free from dirt and dust, chemicals, oils, paints, etc. The adhesive shall be spread evenly with a trowel as recommended by the manufacturer. The linoleum shall be firmly pressed into adhesive within the recommended setting time of adhesive. To give maximum adhesive contact and to secure a bond, the material shall be well rolled with a floor roller weighing approximately 70 kg, working from center to walls. Alternatively, linoleum may be loaded with sandbags at various points until the adhesive has gripped it. After laying and fixing, all traces of adhesive shall be removed from the surface as the work proceeds within the setting time. The surplus adhesive shall never be allowed to remain longer than few hours. Finally, the surface shall be finished with a wax polish recommended by the manufacturer. Alternatively, a coat of emulsion polish may also be applied. A period of at least 7 days should elapse after installation of the flooring before use. During this time, the flooring shall be covered and protected from the effect of other works. Now let's move to the repairing of floors. Let's begin with concrete floor. Here, if that defect crazing is noticed in concrete, it is preferable to remove and redo the concrete. But if the concrete floor shows cracks at junctions, then grooves are to be cut by making use of concrete cutting tool so as to make some predetermined panels. This gap is to be filled with expansion strip or fillers recommended for such work. There are cases when disintegration of wearing surface are noticed due to presence of chemical. In such cases, a rich concrete layer with weld mesh as nominal reinforcement is first provided. After concrete dries up, a layer of epoxy mixed with suitable epoxy resin filler is given. After cleaning the surface with hydrochloric acid, epoxy mortars, generally hardened CK157 by 240, 4% by weight, filler mixture of quartz sand and silica in 3:7 ratio or calcined bauxite grit is applied. Disintegration of concrete floors takes place due to constant dust accumulation in the pores of concrete. Such defect can be repaired by application of sealant like modified phenolic or epoxy resin floor sealant applied in 2 coats. This sealant fills up pores and improves wear resistance. The concrete floors exposed to oil, grease, mild acid, etc. are slowly getting disintegrated in course of time, and application of rubber-based sealant is the best solution to overcome the problem. This defect can be overcome by scrubbing with the electric scrubbing machine with solution of neutral cleaner, that is pH value not more than 10. By doing so, the dirt will get loosened, which can be then removed easily. Formation of stains due to spilling of ordinary writing ink, coffee stain, iodine stain can be removed by various methods. What are these methods? The stains due to ordinary writing ink can be removed by a strong solution of sodium carbonate in hot water mixed with whiting to form a thick paste. It is applied as a layer of 6 mm thick and left to dry up. If color of stain still appears, repeat the above process. Finally, the floor is to be cleaned. The coffee stained surface is mopped with cloth saturated in glycerine, diluted with 4 times its volume of water. The iodine stain can be removed by applying alcohol and covering with whiting or talcum powder. Then we move to marble flooring. Marble floor disintegrated by chemical attack shall be removed and redone. But marble attacked by acids and alkaline will show dull surface appearance or decolorization takes place. Such appearance can be improved upon by routine maintenance by damp mopping and vacuum cleaning, etc. While attending the maintenance work, acid cleaner or abrasive cleaner should not be used. In such cases, even soap solution is avoided. Porous and worn out surfaces should be ground and polished. Now let's move to another flooring, that is PVC floor. What is the problem here? Separation of PVC sheet or tile from the sub base is a major defect. In such cases, the affected tile is to be removed, cleared of the adhesive applied earlier, and paste the sheet with sub-base afresh. Routine maintenance of PVC floor can be carried out by usual cleaner and water emulsion, wax or spirit. While doing the maintenance work, care shall be taken to avoid excessive use of water or flooding of water. Now, the next flooring is rubber flooring. Fats and oils react with rubber and hence soap solution cause damage to the rubber surface. In this case, only synthetic detergents derived from sulfonated hydrocarbons for cleaning shall be used. To remove accumulation of dust, mild abrasion cleaner like steel, wool pad, etc. can be used. Now, linoleum flooring. As far as this flooring is concerned, brittleness, color fading and wax accumulation are the defects. Alkalis are injurious to linoleum, causing brittleness and color fading. These defects can be overcome by cleaning the surface with non-wax stripper, that is neutral cleaner. For removal of stains, abrasive have to be avoided. The usage of alkaline shall be fully prohibited on linoleum flooring. Now cork. The main defects are here discolorization and brittleness. To rectify this defect, clean the surface with number 0 steel wool. The floor shall be swept with soft bristle brush, and occasional buffing with floor machine can give a long life to the cork flooring. As a precautionary measure, avoid alkaline cleaners and naphtha gasoline solvent on this floor. Next is asphalt flooring. The general defects on this surface will be development of cracks and brittle pitting. Dissolving the asphalt due to temperature variation is another defect. In order to overcome these defects, water can be used sparingly and good quality mild soap can be used. For asphalt flooring, the preventive maintenance adopted is to avoid alkaline and caustic cleaner and avoid oil, grease, solvent, varnish liquor. This flooring can be avoided in areas subjected to extreme temperature change. So this way, you saw that we discussed about that what are the common defects in floor, how the repairing of floor can be done. So I hope you must have enjoyed this discussion. So thank you for patiently listening.